Hello and welcome to my video on factoring quadratic equations using a geometric approach, a visual approach. Isn't that cool? More than just, symbol manipulation. So I didn't get this. I didn't develop myself. I got it from a favorite professor of mine, Dr. Steffe. So I just want to give credit where credit's due, and this is just my best, doing my best to represent it. Okay, so let's go ahead and look at something we're familiar with in squares. A little foreshadowing there. So let's forget just a moment that we're trying to factor. These are going to be thought experiments that will lead to understanding quadratics in a new and better way. And some of the exercises we'll do will be apparent. All right, now first, this is a 3x3 square. So it's an area of 9. So we know how to find the areas of squares, rectangles, and that sort of thing with specific areas. But what if we're thinking about either the area or the lengths that are non-specific? In other words, they could be anything generic like x. So yes, these are on certain points, these side links are, but we're going to just pretend we don't know what they are as a thought experiment. So in this case, they're going to be x and x. Okay, so then our area of the square is going to be x times x. Just like before, the area was 3 times 3. Okay, so now let's think about some things that maybe are a little less simple. So how would we find a rectangle that had an area of x squared minus 1? Or actually, it doesn't even have to be a rectangle. It could be any shape. And we think of a shape that if this is x, that our new shape is going to be x squared minus 1. Now pause the video if you want to think about this, because I think these are fun things to think about. All right, unpause. So you just subtract a cube of 1, right? And so what you might notice is that this length here is a length of 1. Gives us the perfect little cube. These aren't going to be exact, but I'm going to get as close as I can. All right, so we're going to go ahead and deduct this. So this is no longer here. So now we've actually got, you could think of this, now this would be, all right, let's complete the whole deduction of this. All right, so what we end up with, what we end up with is a hexagon. In other words, a weird looking 6-sided figure. Not quite as symmetric as we're used to them looking. Okay, but in order to make this a factoring, it actually has to be a square. So when you look at a factor geometrically, that's basically what you're doing. Or excuse me, a rectangle. You're taking two sides, and the area is the design, and then the area of the rectangle is our original quadratic equation. So in this case, what we're looking for is x, use a squiggly, x squared minus 1. So that's not the nicest way to look at it, but that's the symbol we're going to use for now. And so what we can do is look at this in terms of 3 rectangles. Well, that doesn't seem to be working. All right, so one here, and finally one here. All right, and so the green, or the darkish gray one, and the purple one are going to be the same size. And so what we can do is we can take this purple one, and then if we place it onto the side here, we end up with a rectangle, the rectangle we need. Maybe not the one we deserve, but the rectangle we need. Right, and so it'll end up looking something like that. It looks even nicer with fewer time constraints, but that's the idea. And so we remember that the length of each of these was 1. So this went from x minus 1, and this one became x? Well, this whole thing was x before, right? And we're adding on a length, so that'll be x plus 1. Okay. So, in general, how you would view this, well, actually, we'll just call this the introduction. And so in the next video, we'll talk about how to maybe do this. This gives you an idea of where we're going. In the next video, we'll flesh it out a bit more, and how eventually, actually, I shouldn't say eventually, in not too long, you'll be able to use this technique and viewing it this way to solve basically any quadratic. Certainly the ones that have real solutions. All right, well, good luck, and I hope that this was, helpful in some way, and have fun factoring.